All right. Hey guys. So today we're talking 11.1, which is going to be circumference and arc lengths of circles. So this is actually the first part of 11.1, or it's kind of a more of a mashup of 11.1 and 11.2 if you're following in the book at all. Because I like different parts of each to go together versus the way that the book had them. So anyways, here we go. We're starting circles, talking about circumference and arc length today. So we got to talk about a couple of circle words. First, R means radius. You might have heard this one before. It means halfway across the circle. So if we're drawing a picture, here's the center of the circle, halfway across the circle, this would be the radius right there, that length. So the distance from the center to the edge. And then the D stands for diameter. See if I can fit this word here. D-I-A-M-E-T-E-R. Well, close. All right. That means the whole way across the circle going through the center. So if our center is there, going all the way across the circle through the center, that length would be the diameter. All right. So the diameter and the radius have this relationship that one of them is twice as long as the other. The diameter is twice as long as the radius. So if I have the radius as 3, then the diameter would be 6. If the diameter is 12, the radius would be 6. You can find each of them, one using the other. So if you're given a radius and you want a diameter, then multiply by 2. If you're given a diameter and you want a radius, then divide by 2. So that's kind of how those two work together. And those are important measurements when it comes to figuring out what the circumference or the arc length is that we're looking for in these next couple of problems here. So first off, circumference of a circle is the distance around a circle. It's kind of like perimeter, but for circles. So the circumference of a circle, there's a couple formulas you can use. The first one is pi times the diameter. All right, and this is actually how pi is defined. Pi is the ratio of the circle's circumference to its diameter. When you're on your calculator and stuff like that, there's a pi button. Pi is one of those fun, irrational numbers that goes on forever and doesn't repeat ever. It doesn't repeat the same sequence of digits over and over, but it still goes on forever. And so a lot of times it's approximated as 3.14. But now that we're in geometry class, we're not going to use that approximation very much anymore. Instead, we're going to use the pi button so that it gets us the exact value or a more exact value. So that being said, whenever we're using pi, depending on the calculator you have, the pi button might be a actual button that shows up, or it might be a secondary function. So actually, let me grab a calculator where that looks more like one that you might be using. Oh, and this one has it as a button. All right, cool. So if you're using a calculator, it might look like something like this one. That's the pi button. So if I wanted to do pi times something, I would just hit the pi button and then times whatever I wanted to multiply by. And it will treat it like it's a regular number. So pi times diameter is one of our equations for the circumference. The other one you can use is 2 pi times the radius. And these equations are actually the same. It's just that 2 times the radius is the same thing as the diameter. So anyways, here we go. One way that you might see the circumference of a circle problem stated is you might be told something like this. You've got this picture of a circle, and it shows you a measurement, let's say 12 centimeters. All right. So if I wanted to find the circumference, we know that circumference is pi times diameter. So that would be pi times 12. And then there's 2 ways you can write your answer when you're working with pi. You can write it in exact form, or you can write it as a decimal approximation. So the exact form way means that I'm just going to reverse these two numbers and write 12 pi and leave it that way. This is one possible answer, and it's considered exact form. The other answer that you could use with this is using the pi button in your calculator. Go pi times 12. Hit enter, and it gives you a decimal. And I'm just going to round to the nearest tenth. So I'd get 37.7. And this would be considered the decimal approximation. Okay. So we have the exact form way, we have the decimal approximation way. Depending on what you're asked for, either one of these could be correct. So now it's your turn to try. On this version of it, I'm just going to tell you a value, because sometimes you'll be given this, or you might be told, hey, the diameter is 12 or the radius is 7. So in this case, I'm going to tell you the radius is 7 inches. So if you've got the radius, I would use the radius equation or multiply it by 2 and figure out what the diameter is first. So if you want to, you could say, all right, diameter, figure that out, and then use the circumference equation that we just used in the first one. Or you can try your hand at the second equation, the 2 pi times radius. Either way, pause the video for a second, give this a try, see what you get, try it in exact form and try it with decimal approximation, and then hit play again, and I'll go over it with you. Okay, so hopefully you paused the video real quick. Going over this, one way you could do it is take, okay, the radius is 7, so the diameter must be 14, since 2 times the radius gives you the diameter. Then we know circumference is pi times diameter, so pi times 14. Then we know that in exact form, that's just going to be 14 pi. In decimal approximation form, though, we'd want to grab our calculator and go, okay, pi times 14, and we get 43.982. So this is actually, even rounding in the nearest tenth, this is going to round up to 44.0, or just 44 inches. And we should get in the habit of putting units on there as well. Okay, so that's how we find circumference if we're given the radius or the diameter. Now, arc length is almost like a circumference. It's like a piece of a circumference. And so arc length, if we go off to the side here for a moment and look at a circle, arc length is just going to be, maybe I just want this distance right here. Maybe I want just that piece of my circumference. And so arc length is always defined by an angle. So I'll be given some kind of angle here in the middle. Usually it's defined by some angle theta. Theta, that's not a very good one, looks like this. It's a Greek letter, and it's usually used to represent angles. So usually used to represent angles. And so the equation for arc length is going to be the angle theta divided by 360 times pi times diameter. So it's like you're taking a fraction of the circle, because there's 360 degrees in a whole circle. We're taking our angle divided by 360 to get just a portion of the circle, and then times the circumference, the pi times diameter portion of it. So for our first example, we're going to do one with a picture. So let's say I want the arc defined by the angle 93 degrees. And the radius of my circle is 6 centimeters. All right, so now I know the radius is 6 centimeters. I know my angle is 93 degrees. I can start plugging some stuff into my arc length equation. So we can go, instead of theta over 360 times pi times diameter, we can go 93 over 360, since the angle goes on top, times pi. And then this 6 centimeters represents my radius. So my diameter is going to be 12. So pi times 12. And then we're going to type all of this into the calculator. And when you do, here's how I'm going to type it in. I'm going to go 93 divided by 360. And then times pi times 12. And we get 9.7. And on this one, most of the time, unless you get a whole number, when you do 93 over 360 times 12, if you get a whole number there, you can leave it as a whole number times pi for exact form, but most of these are going to be in decimal form. So I'm just going to leave this one as a decimal, 9.7 centimeters. And so what that 9.7 centimeters represents is this length right here. All right, so your turn to try. Using the same process, we're going to have our circle. Here's our angle. I'm going to give you 121 degrees. And on this one, we're going to be told that the diameter is 8 feet. So pause the video for a second, plug these things into the arc length formula and give it a try. Find your decimal answer. And then I'll explain it once you unpause the video and come back. So go ahead and pause the video. Okay, hopefully you're back now. And hopefully you gave it a try here. So going through this one, now our angle is 121 degrees. So that's what's over 360. And then we're going times pi times 8, since 8 is the diameter. So in my calculator, we type 121 divided by 360. And I'm going to do things a little bit out of order this time. I'm just going to go times 8. You can do them, you can multiply things in any order you want to. And then times pi. I did that just to check and see if this all makes a whole number, like if 121 times 8 divided by 360 makes a whole number, but it doesn't. So then when I go times pi, that gives me 8.4 for my rounded decimal answer. So 8.4 feet. All right, hopefully that's what you got too, or if you can see where something might have gone wrong as we typed things in or as we wrote things down. We're going to do one more type of problem today, and it's going to be finding the diameter or the radius if you're given the circumference. So on our first example here, we're going to be told that the circumference is 18 feet. And we want to find diameter. All right. So we know that circumference equals pi times diameter. So I'm going to go and plug in 18, the circumference, for C. So we have 18 equals pi times diameter. Then we have to remember that pi is just like a real regular number. It's 3.1415, a whole bunch of other numbers. And so when I'm working with it in an equation, we're going to use it like a real number. So I'm going to divide by pi on both sides to get diameter by itself. So into my calculator, I'm going to type 18 divided by pi. So 18 divided by pi button, enter. And we get about 5.7. So 5.7 is my diameter. All right. So that's not too bad, right? For our next example, we're going to go, well, what if we wanted to find the radius instead? So for this one, my circumference, and let's say we're given it an exact form as well. Circumference is going to be 64 pi inches. And we want to find radius. Okay, so for this one, same thing. Circumference is pi times diameter. So I'm going to take 64 pi and plug it in for circumference. Now, when you've got something on both sides of the equation and you divide by it on both sides, it cancels away. So if I divide by pi on both sides, just like I did over here, it cancels on both sides since we had pi on both sides. So we're left with just 64 equals diameter. But I didn't want the diameter, right? I wanted the radius. So actually, we're going to go one step further and divide it by 2 because diameter is the whole distance across. Radius is half that distance across. So if I take 64 and I divide it by 2, we get 32 inches, and that's going to be our radius. And that would be our final answer. Okay, so your turn to try. And this is the last one. Ready? For you guys, we're going to have circumference. And we'll have it be 19 meters. And we want to find the radius. So go for it. Find the diameter first, then find the radius. Go ahead and pause the video for a second, give it a try, and then we'll talk about it in just a moment. Okay, hopefully you paused the video and tried it on your own, because here we go. We know circumference is pi times diameter, so I'm going to take 19 and set it equal to pi times diameter. Then we're going to divide by pi on both sides. 19 divided by pi is what I type into my calculator. 19 divided by pi, we get 6.0478, a whole bunch of stuff for the diameter. And the reason I'm keeping that is so that I don't end up with a rounding error later, because the diameter is not my final answer. I'm going to take what I have here and just hit divide by 2 to get 3.0239, a whole bunch of stuff for the radius. So this can actually, if you're rounding to the nearest tenth, one decimal place, this just rounds to 3. So 3 meters will be our radius. And that's all we got to do. All right. So if you're in my class and you're watching this, your homework is going to be on the next couple of pages here. I gave you lots of room to show your work and things like that. So make sure you read the bold directions above each section, where it says like round to the nearest tenth and find the circumference. And then under here where it says find the circumference, but use exact form, make sure you leave pi in your answer on those ones. Find the length of each arc, round your answer to the nearest tenth. Find the arc length in exact form. So leave it as a fraction with pi. Find the diameter given the circumference, round to the nearest tenth, and find the radius given the circumference, and round to the nearest tenth. So you're going to do all 16 of those problems for homework, but there's plenty of room to show your work, so please show your work on the paper. All right, have a wonderful rest of your day. See you later.